Okay, so in this video, let's understand what ROC is. ROC stands for Receiver Operating Characteristic Curve. I'll take an example here. Let's say I have some data points x1, x2, x3, x4, x5, and so on, right? And I have the class labels over here. The class labels are, let's just say that the class labels are 1, 1, 0, 1, 1. These are the actual class labels. And let's say that for an output, I get the probability score as an output. Okay, even if this is not the probability score, this is just some score that helps us classify our points as 1 or 0. I'm just going to say that if y hat is greater than 0.5, the point is classified as 1. If y hat is less than 0.5, the point is classified as 0. And the values that I got for this are, let's say, 0.95, 0.9, 0.8, 0.76, 0.71, right? These are the values that I got. Now, so as you can see that, the first 2 points were classified correctly. The third point was classified incorrectly because for 0.8 because since the class label is 0, we should have received y hat as something less than 0.5, but we got 0.8. So what I'm going to do is now, how do you plot the receiver operating characteristic curve? Okay, the ROC curve is nothing but so if I have two axes, the x-axis has the value of FPR and the y-axis has the value TPR. Okay, so basically my ROC characteristic curve is just a curve that gives me a relationship between TPR and FPR. How do I do that? So let's say that after every data point that I have, I'll take a threshold value tau. Okay, for the first data point, I'll take tau 1. So I'll take tau 1. So for the first data point, it's 0.95, right? I'll take tau 1 as 0.95. And taking this as the threshold value, I will get a value of FPR and TPR, right? See, this is my threshold value, and with this threshold value is something like, if everything above 0.95 will be classified as a label 1, and everything below 0.95 will be classified as a label 0. So for tau 1, my y hat is actually 10000, right? So for tau 1, I can get a value of FPR and TPR, right? We have seen this using the formula from confusion matrix. Similarly, what I'll do next is, after having found the FPR and TPR value for tau 1, I'll take a value tau 2, okay? So tau 2 says that, so because I've taken threshold 2 over here, tau 2, every value that's above 0.9 will be classified as 1, and every value below 95 will be classified as 0. So I have 1, 1, 0, 0, 0, right? Every value below tau 2 will be classified as 0. So tau 2 equals 0.9 will give me another value of FPR and TPR, right? Similarly, I'll take tau 3, I'll get the value of FPR and TPR. Tau 4, I'll get the value of FPR and TPR. Tau 5, I'll get the value of FPR, TPR. So I'll have tau 3, then I'll have tau 4, then I'll have tau 5, so on and so forth. Okay, FPR and TPR, right? I'll get the value over here for all of these taus. So when I have the values of FPR and TPR for each tau, I can plot a curve, right? The curve might go something like this, correct? This curve that we get from taking a tau value and plotting the FPR and TPR for each of the tau values is called the receiver operating characteristic curve. This is a very important metric because it's very, very useful in your classification problems. Look, basically, what we want is that we want the TPR to be as high as possible, and we want the FPR to be as low as possible. So ultimately, our ROC curve should stretch towards the upper left corner of the graph, right? Generally, the TPR FPR graph is given in a square box if you ever draw it in Python. And this curve, the more it's stretched towards this upper left point, the better it is for our model. And the area under this curve, let me just change the example. The area under this curve is basically area under curve, and the best value of area under curve should be zero point 0.1. Ideally, for the best value of the model, we want the area under curve to be equal to 1. I'm sorry, 1, not zero point 0.1. So if this graph ROC curve stretches to the upper left corner, we'll ultimately get the AUC as 1, right? AUC will tend to 1, correct? Because if this stretches to the upper left corner, this will become a square. And if this is 1 unit length, this is 1 unit length, we'll get the AUC as 1. So this is what the AUC curve is all about. Okay, so ROC is used for binary classification only. That's important to note. This ROC curve that I told you is used only for binary classification. Only for binary classification, right? AUC can also be high for a dumb model. So this technique is not prone to imbalanced data sets. AUC can be high for a dumb model. Can be high for a dumb model. Okay. AUC depends on the ordering of the data, not the value of the scores. Okay, so over here, what we have done is we have sorted the scores in descending order of the probability that the model gives us the output as. I forgot to mention this in the beginning. You have to sort the data points in descending or ascending order and then take the value of taus. Okay, so AUC depends on the ordering of the data, not the value of the scores. Okay, and then fourth point is AUC of a random model will be 0.5. Of a random model will be 0.5. Now, what does it mean that AUC of a random model will be 0.5? Okay, so over here, it's important to note that I'm using the term random model, not dumb model. A dumb model will basically give one class value to all the data points. A random model will randomly assign data point values to all the data points, okay? Just randomly, it'll just give 1, 0, 1, 0. So if it ultimately gives you, 1, 0, 1, 0, if your model is random, then your AUC will be a straight line from the bottom left corner to the upper right corner. Okay, this will be your ROC curve, and your area under curve will be this. The value of this will be 0.5. This is a random model. So 0.5 is used as a baseline to understand how well your machine learning models are doing. Because if you get an AUC under 0.5 for a machine learning model, then ultimately your random model is better than your machine learning model. You don't even have to go through the headache of cleaning your data, processing it, trying different models, hyperparameter tuning, and checking where it works well. Because if it's performing worse than a random model, then it's pretty useless. So the AUC for the random model will be 0.5, and we use that as a baseline. So every time the ROC curve is above this diagonal, right, through this graph, the better it is. The more higher, the more it stretches to the top left corner, the better it is.